Hello everyone, welcome to the ITLS Academy. Today we are going to discuss the topic that is your solution preparation. Solution preparation. Okay, so before starting the lecture, we have to know that what is this solution? Okay, so solution is defined as a homogeneous mixture of two or more compounds. Here, the homogeneous mixture means that the composition of the compound is uniform. Simply, solution is what? Solution is the homogeneous mixture of two or more compound. And here the compound is what? Either it is solute or solvent. Okay, solute is always in smaller amount and solvent is always in larger amount. Solute are either solid or either liquid, and this solvent are what? It is liquid in state. Okay, so according to solute, either it is solid or either it is liquid. The solution is of two types. One is your solid into liquid, and another one is your liquid into liquid. Okay, solid into liquid means that the solute is solid and the solvent is liquid. That is called a solid into liquid solution. The second is your liquid into liquid solution, in which the solute is also liquid, and solvent is liquid. Okay, so this is how the solution are divided. Now the next, there are some terms that we are use. The first one is your solubility. Solubility is simply means that the ability of the solute to dissolve into solvent. It is called solubility. The next is your standard solution. One is your standard solution, one is your stock solution, and another one is your working solution. Simply, the standard solution are defined as the concentration of the solution is known. The concentration of the solution is known. Okay, that means that the weight and the weight of the solute and the volume of the solvent is known. Suppose that someone said to you, prepare a 5 gram of NaCl in 100 ml of distilled water. So in that type of solution is called what? It is called a standard solution, in which we know the weight of the solute and also the weight of the solvent. That is the 5 gram weight is what? Weight of the solute, and the 100 ml is what? It is the volume of the solvent. The next is your stock solution. Stock solution are always in a concentrated form. Okay, It cannot be directly used. If we want to use that stock solution, first of all, we have to dilute it. And then this stock solution are converted into a working solution. Okay, so working solution is defined as the dilution of the stock solution. Dilution of the stock solution. Now, what does this dilution means? So simply the dilution is what? When we decreasing the concentration of the solution. And how we decrease the concentration? By adding solvent, and especially the solvent is what? It is a water. This is about the dilution, working solution, stock solution, standard solution. Now the next is your types of the solution, or how many types of solution we can prepare. First is your molarity or molar solution. Next is your normality or normal solution. Then stock percentage solution, stock solution, working solution, conversion of percentage into molarity, and conversion of molarity into percentage, and at the end X solution. So we have to discuss 1, 2, 3, 4, 5, 6, 7, 8. 8 type of solution preparation. The first one that we are going to discuss is about the molar solution. Now we all know that this molar solution is the most common type of solution. We make a molar solution, we have to know the molarity. Okay, when we have to prepare that molar solution, when we have to prepare the molar solution, we have to know the molarity. Now, what is this molarity? Molarity is simply defined as molarity is defined as the number of moles per liter of solution. Formula of molarity is what? M is equal to number of moles divided by volume in liter. The unit of molarity is always liter. That we have to remember, that the molarity, the unit of the molarity is what? Is always in liter. Okay, it is the ratio of the moles of solute and the liter of the solvent. Now for the, this is about the molarity, and this formula is for a molarity. So for the for the calculation of the molar solution, we calculate it by two way. Okay, one is your solid reagent for a solid reagent, and the next is your for a liquid reagent. Okay, so the first formula is for a solid reagent, that is equal to weight is equal to molarity multiplied by molecular weight multiplied by volume in liter divided by 1000. Here I divide this equation with 1000, sorry, volume in ml, not volume in liter. Here it is volume in ml. So here I divide this equation with 1000 because, just a minute, volume given, not volume in liter, volume given. Okay, so I divide this equation with 1000 in that case when the volume are in ml. Okay, if there is a question in which it is written that we have to prepare it for 100 ml, for 250 ml, then in that case we have to divide it this formula with the 1000. And if it is given in liter, then in that case this 1000 will not be added into the formula. So simply the for a solid reagent the formula is what? Molarity multiplied by molecular weight multiplied by volume given. And in for liquid reagent this formula is what? First of all we have to calculate the molarity of the stock solution, that is equal to specific gravity multiplied by percentage purity multiplied by 10 divided by molecular weight. Okay, so in that case the specific gravity, percentage purity and molecular weight are given into the chemical bottle. And for the solid reagent, the molecular weight are given into a chemical bottle and molarity and the volume are given into the question. Now, come to the liquid reagent. When we find out this when after finding out this molarity, we have to use a formula M1V1 is equal to M2V2. Okay, so in a question we have a M2V2 and we don't know about the M1V1. So first of all we have to find out M1. Here M1 is what? M1 is equal to molarity of the consent, sorry, molarity of the stock solution. V1 is equal to volume of stock. M2 is equal to molarity of working and V2 is equal to volume of working. Now we know that M2, we know that V2, and with the help of this formula we calculated the M1. Now this formula are become V1 is equal to M2 V2 divided by V1. Sorry, divided by M1. With the help of this, we calculate the volume of the stock solution. I think uh, till now it is clear. Now, suppose that we have a 5.844 gram of NaCl. It should be dissolved into a directly of 100 ml of distilled water. So it should be dissolved directly. But in case of liquid, if we get a 5 ml of this V1, and in question it is written that we have to make up volume 100 ml. So what we do, first of all, we take a cylinder in which the in which the measuring cylinder in which 100 ml are mentioned. So first of all, we add a 5 ml of stock and make up volume 100 ml. That means that the remaining distilled water will be at 95 ml. This is how we um, make up volume for a 100 for make up volume in case of the liquid reagent. So this is how we prepare a solution. If we have that is how we prepare a molar solution. Either we have a solid reagent or either we have a liquid reagent. So for you there is a two questions I'm going to write down here. One is from the solid reagent and one is from the liquid reagent. You have to solve and send the answer to the comment box. Now the first equation is for first question is for the solid reagent. Okay, so for this you to prepare a 2 molar of NaCl in 250 ml of distilled water where the molecular weight of the NaCl is 58.44 gram per mole. And the next question is for the liquid reagent, or you can say that liquid chemical. If we have a liquid chemical, first one is your solid chemical and the second one is your for a liquid chemical. In that case the question is to prepare a 0.2 molar of HCl in 150 ml of distilled water where HNO3 HNO3 where the molecular weight of HNO3 is 69, percentage purity is equal to 70% and the molarity is equal to 0.2 mole. Now you have to find out that either it is M1 or either it is M2. Percentage purity and the specific gravity is 1.4. Now solve this question and write down your answer into a comment box. This is all about the molar solution. We discussed both the formula for solid chemical or for liquid chemical. Now you have to solve this equation. Now the next is your normality or a normal solution. Now next is your normality or normal solution. Like in your laboratory, you see that in a reagent bottle, it is written that 0.1 normal of NaCl or 0.5 normal of NaOH, 1 normal of like CMC. So this is how we are going to see that how we prepare this normal solution. Simply the normality is defined as normality is defined as the number of equivalent weight per liter of solution, or N is equal to number of equivalent weight divided by volume in liter. Okay, so for this, first of all, we have to calculate this number of equivalent weight. Okay, now equivalent weight are calculated different for a different type of the solution. Like for a base, it is calculated for a different way. For an acid, it is calculated by a different way. Or for a salt, it is calculated by a different way. So the first one is your equivalent weight of acid. For this, the formula is molecular weight divided by a basicity. Now we all know that the molecular weight are present in a chemical bottle. But how we calculate this basicity? So simply the basicity is defined as number of replaceable hydrogen ion present in hydrogen atom present in acid. Okay, if 2 present, then the basicity will be 2. If 3, then the basicity will be 3. This is how we calculate the basicity. Now, for acid, we all know that the formula is what? Number of equivalent weight is equal to molecular weight divided by a basicity. Now, if we take a first question or first example, we have to calculate the number of equivalent weight for HCl. Okay, so we all know that the molecular weight of the HCl is what? 36.5 gram per mole. And the basicity of this HCl is what? See here, one is your Cl, chlorine, and one is your hydrogen atom. That means that one hydrogen atom is replaceable. That means that the basicity is what? 1. Now put this value into the formula. Number of equivalent weight is equal to molecular weight is what? 36.5 and the basicity is 1. So it is 36.5. HCl is the acid in which HCl is the acid in which the molecular weight and the equivalent weight are equal. That is 36.5 or 36.5. Another example is H2SO4. Okay, molecular weight of the H2SO4 is 98. And here you see that two ions of two atoms of replaceable hydrogen atoms are present. That means that the basicity is what? It is 2. Now put this formula, put this equation into the formula. That is number of equivalent weight is equal to 98 divided by 2. That is 49. So this is how we calculate the equivalent weight in case of acid. Now the next is your for base. So in that case, the number of equivalent weight is equal to molecular weight divided by a acidity. In case of acid, the molecular weight are divided by a basicity, then we calculate the, then we get the equivalent weight. But in that in the second case, that is your for base, in that case we divide the molecular weight with the acidity and we get a number of equivalent weight. Now how we calculate the acidity? Acidity is defined as the OH group present in a base. Okay, that is called its acidity. Now, if we take a first example, that is your for NaOH, the molecular weight of the NaOH is 40 and the acidity of the NaOH is what? Here only one OH group is present. So in that case the acidity is what? Acidity is 1. Now put this equation into that formula, that is equal to 40 multiplied by 1, that is equal to 40. So here hence prove that NaOH is a base in which the acidity, sorry, in which the molecular weight and the equivalent weight is equal. That is 40. Now the another example is CaOH का whole twice. That is called a calcium hydroxide. Okay. So for this, we know that here what? Here two OH group are present. Two OH group, replaceable OH group are present. So that means that the acidity of calcium hydroxide is 2 and the molecular weight is 74. So when we put all these value into the formula, then we get number of equivalent weight is equal to 74 divided by 2, that is 37. Now if we dissolve this 37 gram of calcium hydroxide into 1 liter of distilled water, then we get what? 1 normal of calcium hydroxide. Same here, if we dissolve 40 gram of NaOH into a 1000 ml of distilled water, then what we get? We get a 1 normal of NaOH. This is how we calculate the number of equivalent weight in case of base. Now, the next is your equivalent number of equivalent weight, number of equivalent weight of salt. That is equal to molecular weight divided by valency. Okay. Now see the first example, that is NaCO3. That is called a sodium bicarbonate. Okay, so in that case, sorry, Na2CO3. In that case, the valency of sodium bicarbonate is 2. and the molecular weight of the sodium bicarbonate is 106 gram per mole. Now put this value into the formula. Equivalent weight is equal to molecular weight 106 divided by 2, that is equal to 53 gram. Now if we dissolve this 53 gram into 1000 ml of distilled water, then we get what? 1 normal of this sodium bicarbonate. Now the next example is equivalent. We have to calculate the equivalent weight in case of NaHCO3, that is sodium, sorry, the first one is your sodium carbonate and the second is your sodium bicarbonate. Okay, so here the valency is what? Valency is 1 and the molecular weight is 84. Now 84 divided by 1, that is 84. If we dissolve 84 gram of sodium bicarbonate into 1000 ml of distilled water, then we get a 1 normal of sodium bicarbonate. The first example is for a sodium carbonate and the second example is for a sodium bicarbonate. Now the next is your, the normality is then calculated as a N1V1 is equal to N2V2, where N1 is what? N1 is the normality of the stock. V1 is the volume of stock. N2 is the normality of the working. And V2 is the volume of the working. When we put all these into the formula, then we get the normality. This is how we calculate it. So we completed two topic. One is your molarity and another one is molar solution or molarity and another one is your normal solution or normality. Now the next is your percentage solution. Now the next solution is a percentage solution. Okay, so this percentage solution are either prepared by a weight by weight, weight by volume, or volume by volume. So if you see the first case, that is your weight by weight, in that case the solute and solvent both are solid. In the second case, that is weight by volume, in that case solute is solid and solvent is liquid. Now the third case, that is V by V, volume by volume, in that case the solute and solvent both are liquid. Okay, so first that we are going to discuss is a weight by weight. Weight by weight is defined as 10 percentage weight by weight solution contain 10 gram of solute in 100 gram of solvent. Okay, if we talk about the weight by weight, then if we see that the 10 gram, that means that 10 gram of solute present in 100 gram of solution. Now the next is your weight by volume. Weight by volume is defined as 10% of weight by volume solution contain 10 gram of solute in 100 ml of solution. That is called a weight by volume. So now the next is volume by volume. So the 10% volume by volume solution contain 10 ml of solute, 10 ml of solute in 100 ml of solution. This is your percentage solution, or simply it is calculated. Suppose that in an equation it is said that you have to prepare a 10% of ethanol. Now what we have to do, we have to prepare it for 100 ml simply. So what we do, we weigh 10 ml of ethanol and dissolve into a 100 ml of this, no sorry, dissolve into a 90 ml of distilled water, because it is a liquid case. 90 ml of distilled water, or you can say that the makeup volume 100 ml. So this is how we calculate the percentage solution. Now the next is your stock solution. See, stock solution are, we all know that it is what? It is a concentrated solution. Okay, and it cannot be directly used. It can't be directly used. We have to dilute it. Now this stock solution are either molar solution or either normal solution or percent solution. Simply. So we use the same formula that we discussed. In case of molar, we have two formula, that is solid for different, and for liquid it is different. So we calculate it according to it. And for normal, that formula that we discussed, and for percentage solution, same as it is. Now the next solution is your working solution. So for working solution, we use a formula that is C1V1 is equal to C2V2, where C1 is equal to concentration of stock, V1 is equal to volume of stock, and C2 is equal to concentration of working, and V2 is equal to concentration of, sorry, volume of, not concentration, it is a volume of working. Okay, so this is how we calculate working solution with the help of the stock solution, and how we calculate the stock solution is already discussed. So we completed these things: molar solution, normal solution, percent solution, stock solution, and working solution. All these are completed. Now the next is what? Conversion of percentage into molarity, or conversion of molarity into percentage. Our next topic. Now the first is conversion from percentage into molarity. So simply we use a formula that is equal to conversion of conversion from percentage into molarity. So molarity is equal to percentage solution multiplied by 10 divided by functional weight or molecular weight. FW is what? FW is your functional weight. It is also called a molecular weight. Now the next is your conversion of conversion from molarity into percentage. So for this we use a formula, that is percentage is equal to molecular weight multiplied by molarity divided by 10. So here the first case is your conversion of from percentage into molarity, and the next case is your from molarity into percentage. Clear it? Now the next is your, now the last solution is your X solution. Okay, X solution is your what? It is a buffer solution. For example, if you have to prepare a 1x, 10x, 2x, 50x, or 10x, 10x TA buffer, like that. Okay, so here the formula that we are going to use is C1V1 is equal to C2V2, where C1 is the concentration of stock, V1 is a volume of stock, and V2 is a volume of working, and C1 is a concentration of working. Simply this is how we calculate it. Now again, a one question for you. You have to prepare a 50x TA buffer. Sorry, how to make 1x buffer of volume 500 ml from 50x buffer. So here it is clear that we have a C1. C1 is what? C1 is a 1x. We have a V1, that is 500 ml. Sorry, C2. This is a working. So this is the second one is your what? C2. C2 is equal to 1x. V2 is equal to 500 ml. C1 is equal to 50x. The concentration of the stock is what? It is a 50x. And we have to calculate the volume of the stock. So simply the formula that we are going to use is C1V1 is equal to C2V2. Now we have to calculate this V1. So V1 is equal to C2V2, that is divided by our C1. Now put all the values into the formula. Here C2 is what? 1 multiplied by 500 divided by 50. So it is 10. So V1 is what? V1 is 10 ml. Now what we have to do? We have take a beaker, take a measuring cylinder of 500 ml. Now into it, first of all, I am going to add a 5 ml of 10 ml of our stock, not 5, 10 ml. 10 ml of our stock, and makeup volume 500 ml. That means that we add 490 ml of distilled water. So this is how we Prepare a 1x buffer of volume 500 ml with the help of the 50x buffer. So this is all about the solution preparation. Here we discuss a molar solution, normal solution, percentage solution, stock solution, working solution, X solution, and along with it also see that the conversion of percentage into molarity and the molarity of the percentage. I hope you will understand, but if you have any query related to this topic, you can ask me in a comment box, or for a further detail, you can follow the ITLS Academy on different platforms, that is Instagram, Facebook, Twitter, YouTube, WhatsApp, and LinkedIn. And subscribe our channel ITLS Academy on YouTube and get our app from a Google Play. You can also ask your query to the helpline number that are already mentioned in your slide. That is 7080833450, and visit our website www.itlsacademy.com. Thank you for watching. Please like, share, and subscribe our channel.